Well, we got a fun question to use a previous result that we found. And I never would have thought this would happen, but let's go ahead and get some more practice in. The statement reads, show that the potential representation automatically satisfies the contravariance gradient of the dual tensor G mu nu is equal to 0. Okay? So the 4 vector and the field tensor is equal to this, where we have the potential 4 vector of v over c and then all the coordinates of the vector potential. And this is how we wrote the potential formulation for f mu nu with respect to the derivatives. Again, let's be careful of the notation here because it's going to get hairy. Let's see what we got. All right, so we previously showed that this derivative of the dual was 0 is equivalent to this expression here. In fact, I think it was in problem 12.54. That being said, we can use this result and start tidying things up with it. With this equivalence, we can quickly substitute in the potential formulation and verify that it satisfies the derivative of the dual equals 0. In the shorthand, the potential is written as F mu nu is equal to D mu A nu minus D nu A mu, block cross terms, of course, and we can lower it accordingly. So let's do this and plug it in. We see that the shorthand for this expression here is given here. And if we plug in what we need to know, where f of mu nu is, plug in matching everything that we need to. Then we have f nu lambda, so plug in the changes. And then we have f lambda mu, plug in the changes there as well. And then again, it all equals 0. And if we distribute everything and we get the double derivatives here, double, 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 what we did was we distributed the lambdas, distributed the mu's, distributed the nu, and then we joined together the color coordinated pieces, which is nu nu, lambda lambda, and mu mu. And if that's the case, what we showed earlier was the fact that this arrangement, the double derivatives of it, is equal to 0. That's what we needed to show. And if each part of these is equal to 0, then we get 0, 0, 0 is equal to 0. So yeah, this does satisfy everything. It's a messy kind of situation. If you're not careful with labeling, of course it's going to get blown out of proportion really quickly. But if that's the case, then this type of setup does automatically satisfy it. And I think we have to note here the reluctancy or the built-in symmetric nature of these derivatives in the last part there. But again, if you can get used to this notation, these proofs become pretty quick. Although you still have to get, again, used to it. But once you can group things like that, oh, easy money. That being said, we have a few more like this, and I'll see you when we get there.